Hello everyone. In this set of videos, we will dive deep into low-level design. I won't exactly cover different design principles or design patterns. You're happy to study on your own for that. In this series, we will try to uh, solve popular interview questions. So let's get started. So for the first problem, I'm picking a rather simple one. Let's say that the interview ask you to design a tic-tac-toe, and that's it. That's the problem. So as soon as the interviewer uh, says that design a system, then the first thing you should do, the first step I would say, is to have is to clear the requirements on what the interviewer exactly wants you to design. So in this section, you'll mostly be asking what questions you should ask the interviewer with respect to the system design segment. So you might try to gather the requirements for it. So let's say for a simple system design thing, what is the first thing which you'll ask the interviewer? So I can give you an example. So you say something like the game usually is played in 3 by 3 grid. Should I implement it in a 3 by 3 grid, or it should be n cross n? So here the interviewer might say anything, but for the sake of simplicity, let's uh, let's go with 3 cross 3. Okay, 3 cross 3 grid, board, whatever. Another thing which you can ask, or not just questions in general, you can ask how you want the system to be as well. So you can ask, for example, how many players should play the game at a time? Is it a regular 2 players, or can there be k players? So just for simplicity, let's go with 2 player. And now the usual rules apply, and you can just state how the game goes. For example, players will take turn one by one, and as soon as there are 3 consecutive rows or columns or diagonals, 3 consecutive rows, columns, diagonals. So then you say that a player has won. And if all the cells are filled, if all cells are filled, and there is no 3 consecutive of any particular one player, then you can say that game ends in draw. Game ends in draw. Okay, and what can be the other requirements? I mean, that's all which I can think of at the time, but uh, it might be the case that while designing the system, you might add something here, although that might look negatively on the interviewer. But if it's not a huge detail, for little minor ones, that shouldn't be a problem. So after discussing the requirements, your second step should be to have a high level diagram of what all classes should be there. Okay, we can like classes identification, something like that. So let's start from the uh, very basic of the game. Okay, so what does the game have? What are the entities in a tic-tac-toe game? Well, surely there's a grid. I mean, there's a board, the 3 cross 3 board. So one class I can think of is board. At this point, you should I mean, you can also list the classes here. Let's just list it here. So the classes which I can think of at the moment will be my board class for sure, because what are the entities? It's a board. A board is basically a 3 cross 3 grid. What are players? Player is an entity, so player can be an entity. What is the other entity which you can think of? I can't think of anything else. So let me just name, the game entity, because we need a class who can control the overall flow of the game, and which will switch turns and check on each level if some player won or if it's a draw. So we need a game class for that. Okay, so these are the three classes I can think of at the moment. However, design is very subjective thing. You can have any other entities as well which might not come to my mind. That is why some designs are better than others, but there is no measure. There is no one solution to all thing here. It depends on how you're interacting with your interviewer and how you're writing the details or documenting it. So let's get started without further ado. So first class, let's start with this person class. A player, whatever. Let's go with the player class. And every class, as you would know, they have private members and public members. So let's say that the private members of this player, what can be the private, what are the elements, what are the variables in this class? What can you think of? You can go, what are the important things? uh, how do you play usually tic tac toe? You play it with X or O's, right, or any symbol. So one thing I can think of is a symbol. Okay, and you can also have a name, although it doesn't really matter, but okay, let's have a name as well. Player will have a name. Okay, before that I forgot to include forgot to have my include statement. So include, what is that, bits slash std c++ dot h. I'm not sure if I'm right or wrong, but anyways, we can look into it later. Using namespace std, and then over here we have declared our private variables. Now what can be the public thing here? So every constructor would fall into this. So I'll have a constructor written down here. The construction should be initialized with my with a symbol. That's how I want my design to be, and this is the way of writing things in C++. Although language shouldn't be a barrier for a design interview question. You are free to choose your preferred language and code it up. Doesn't really matter. All right, so this is done, and we can also have, so the in your public functions, you should always include getters or setters or whatever, because you don't want the user to directly access your private variables. So that is why these are important. Okay, so get symbols, and what this would do is you can write return symbol, right, because this will be the value which we will pass. All right, so I think that is done. You can also have a get name, not really required, but okay, whatever. And now let's move on to a much better class. There are things to code this up again. You can also start with the main class, because that's where your execution starts. So earlier, like, gathering the requirements and identifying the classes is okay, but then the problem arises that which function should you have on in which classes. So I think a better way to solve this is to have some, you start from the bottom. Yeah, you start from the main function, right? So I'll have my main function, and I can in this main function, it's basically how my what is the test thing of how my program is starting. So I can have a game class. I'll have a game object because my main will call my game. In my game class, I can have some function, let's name as play, whatever. So game.play will start my process, and at the end, I mean, it's just to end the program. So now we know that we need a game class, because that's our, we need at least a play function in our game class. And I think that information is enough to start coding in the game class, and at least make the play method, and then further on we will realize what all methods we need. Although it's also a good practice, because we know in a tic tac toe design, we know how the game is played, so we know what functions can be there, because there should be one function to fill the cell with a particular symbol, one function to maybe validate if the player can fill in that cell, because if it is already filled by some other player, or if it's out of bounds, so those things also. So and then also you will need a function to check the winner and check the draw and so on. So it's better to start with any approach, whatever you feel comfortable in, and things, because you go back and forth in your classes and edit it, right? So in our game class, what will be our private members? So game is what? Game is our wrapper class, right? What does the game consist of? Game consists of a board, right? So we need a board class here, which we haven't yet filled. But okay, we need board. And then we need two players, because we identified in our requirement that we will have two players. Okay. And then we also need to keep a track of who our current player is. So I'll just make a pointer because I just want it to point to a particular player. I don't want it to have to make another player object, because then I might run into problems later. Okay. And for the public methods, what I will do, first thing is constructor, of course. So constructor is simple. You just, if you want to pass a parameter, you can, but I don't think so we need a parameter. And I'll just initialize my players with their symbol, because that is how I'm writing the constructor of my players, right? So there is a character passed in parameter while declaring one. So one player is X for sure, and another is O. So this is done. And on the next part, we want a current player to be pointing to some player, right? So I'll pass the address of my, let's say, player 1 in this case. Okay. And another function, the main function which we have to write, is play, because that we wrote it in our main function. So in this void play, so how is the execution of the game? It depends on you. So I want my players to have turns again and again until someone wins the game, or it ends up in a draw. So, and before that, yeah, and I can also, so the first thing would be to ask my player what row and column do they want to fill, right? So for that I can have this, and since it's a pointer, so I can access my method using the arrow function, and it's basically get symbol, because we wrote it just to tell which player's turn is. Okay, it will change, and we can have enter whatever row and column, and yeah, and I think the next thing would be to get input from my player. It should be my row and column. All right, And now I would want to check the validity of this entered column. So if my board dot valid what can we name our function? Naming function is one more thing, but okay. Valid move, we can have like something is valid move, makes more sense. And here I will be passing my row and column. So if it is not valid, then what do I want? I want my player to again enter it. So I don't want the game to end. I will just start from the beginning, right? So, and I can also write a comment that invalid move whatever, and then I can continue because I want this to get the input again from the user. Okay, and if it is valid, then we move on ahead. So now we want to, if it is valid, we want to fill the particular row column with that particular symbol, right? So I'll have my function, I'll name it fill cell. I will have my row column and my current get symbol, right? My current get symbol. Yeah, this is a function. Okay, so now I have filled it. Until now, I mean, we kind of know that our board is having functions and we need to fill them. But okay, let's go ahead. Let's go ahead in our journey and try to write the rest of the code. After the cell has been filled, what do you do in a tic-tac-toe game? In a realistic game, you check if the entered cell makes any of the makes you the winner. So I'll have this method which will also be in the board class. We'll name it maybe check winner, and in this I will pass the function, pass the current this thing, the symbol. So if x's are any three together in row, column, or diagonal or whatever, then we can declare that as a winner, right? So if my winner is, I'm passing that character as an argument. If that is the case, then I basically want my check function is okay. Oh, we are again missing. Okay, 1 second. Yeah, so if this is a winner, I'll of course have the message that you win or whatever player, and then current get symbol, you wins basically, right? And then I break because that is my end of the game. My game has ended, so I need to get out of this while loop. And in order to get out, I need to write a break. Okay, so this function is again something which we need to write. We need to check the winner. Now it's not always the case that someone will win. It can also end up in a draw, which we have already stated in our requirements. So we'll have another if condition to check if the board is full. If the board is full, then it means that we have drawn the match. No one won. So then we can have what? No one wins. See out. Game's a draw. Okay. And it would be better to also show the user before every turn what the current position of the board is, because it's a console game, right? So I'll also have a function which will just simply display. So board.display, and after the game has won, we also want to show it again. So board.display, and same thing for the draw, board.display. Okay, and then again we break it because our game has ended, no one won. And now all these things is done. Now once a player has made his move and none of these things has happened, then what it means, the game goes on, so the next player should uh, enter there, so the player turn should switch. So if my current player is basically P1, then I want my current to be pointing to P2, and if that's not the case, my current, if it is pointing to P2, I should point to P1. Okay, so this is how our game flow works. Now we need to fill our board class, create our board class, and fill the details. So all of them are done. We just need our board class. A board class, what will be the private functions? Private members. Private members, what is there in a board? Board consists of a grid, right? That we want. We want another variable, let's say size. Size, since we have said it's a 3x3 board, so size will be 3. And I also need a grid, a 2D vector of chars. We can call it grid, and that is done. And I think for in the public we will have the constructor. Board won't be passing anything because its size is fixed anyways. If we want to, I mean, this you can say it now also if you want, but if we want to change the size, we might use a variable size here and then pass the size in the constructor to make the grid of that particular size. It will add complexity, but okay, it can be done. That is why gathering requirements is the most important thing in any low-level design problem. Okay, so once this is done, I'll just make my grid. I'll initialize my grid with the empty cells. So vector, char, and then I want it to be size, which we have stated. Vector, char. This is just the way it depends. I think for every language it's different, but you get the idea that what we are doing is just making an empty grid of 3x3 with blanks, right? Okay, so this is done. Constructor is done. Now we can start filling our functions. So what was the first function we wrote? Is valid move. Okay, so this will either return true or false, we know. So bool is valid move. What are we passing? We are passing two arguments, row and column. Let me denote with R and C. Now I can say, when is a move valid? Firstly, that it should be in the bounds. So my R should be greater than equal to 0, and my R should be less than size. And same goes for my column. My C should be greater than equal to 0, and my C should be less than size, and it shouldn't be filled because I can't overwrite. So grid of R and C should be empty. Okay, if this is the case, we return that it's valid. Return true. And else we return false. Okay, another function is fill cell. And this is a void function because we are not really doing anything. We're just filling it. Fill cell. What are we passing in this? We are passing the row, column, and my character of ch, because symbol is a character. So in this is pretty forward. Just create rc is equals to ch. Okay, this is done. What is the next function? Next function is to check winner and is full. Okay, so check winner again will be a boolean thing. I think this is the only part of the interview where you need to code something. So what are we checking? We need to pass a character, right? Let's name it ch. Check winner. It should return true when either three consecutive rows in a row, three consecutive, in a column, three consecutive, or diagonal, three consecutive. If these things are satisfying, then we can declare the player as winner. So first let's do a row check. Okay, so I'm checking for every row starting from 0 till size. Let me also have a pool check variable here. I'll initialize it to true. This logic you can write it anyway. I'm just writing whatever is coming in my mind. J less than size and j plus plus. For this, what are we checking? All for a row I, all of the grid ij should be the same character, and we have already passed that character. If ij is not equal to that character, then we know that it's a problem. We are not winning. So what I can do is I can name my variable as false, and I can break this. And then later, after this thing is ended, I can check. If my check is true, then I know that my row has matched. So return true, right? And similarly, we'll do for columns. Column check. What will be changing for columns? It will be just I can be changed to j, and j can be changed to I. The fuck? Yeah. So yeah, I think the other things remain the same. And the last thing would be to have a diagonal check. And as you know that there are two diagonals, so for the diagonal we'll again have our check variable, initialize it with true, and then for I is equals to this thing, size I plus plus. If my grade I is not equal to my ch, then I can say this check to be false, and I can have this condition. If my check is true, return true. This is one diagonal. Another diagonal, so we again have to declare that variable to true. I just copy this. And this would be this should be size -1 minus I. So this is basically the anti-diagonal. Okay, I hope you understand this. And again, if this is true, then this is true. If none of the conditions meet, we just say false. This is our check winner. What is the other function? Is full. Pool is full. Are we passing anything in this? No. So I think this should be straightforward. We'll have this loop int I is equals to 0, I less than size, I plus plus, int j is equals to 0, j less than size, j plus plus. And then if any cell is not empty, then it should return false. So if my grade I j is equals to at any point this thing, then I can simply return false, else I'll return true. Cool. And at the last display function, it's straightforward again, void display, and then I think I'll just copy this. Remove this thing. Cout grid ij. Remove this whole thing. Just spaces for them. And yeah, that looks good. Cout. Just change the line here. This looks good. Okay. And I think that's the design part. I think we have covered everything. I don't know if I can run it in this, but okay, we'll see. But anyways, this looks correct. So at this point, when you are done with your coding part, and also remember that in between, you and your interviewer are having chats. So you basically need to tell why you are doing something. What is the use of it? So after all these things are done, you might want to do a dry run, which is fine, which you can do on your own. And if that is also done, you can further discuss on the time complexities of it. So you can say that, so this, all the functions, this function, this function is taking what, big of 1, this is big of 1, this is big of 3 times 3, and so on. Okay. Space complexity is also constant, right? So now at this point, it is possible that the interviewer might ask you some follow-ups. So for example, like I said, that how would you extend this to an n cross n board, or what if there are k players, anything like that. So here you should try to answer those questions. For the n cross n part, what you can simply do is you can have this variable here as variable, and then in the constructor you can pass n while declaring the board, and so on. You will declare this size, this will stay the same, and then your these methods might also remain the same, and so on. So you get the idea of what we are actually trying to do, right? So yeah, if there are k players, then what you can do, you can answer that. So if I am asked that question, I'll simply answer that I will declare a vector of players depending on the players I have, and the size of the vector should be determined in the constructor only. And then instead of using a pointer, I might use an index thing. I'll use an integer, so I'll initially point it to 0 and then increment it by 1 and modulo the k times whatever. So with this method, I think we can do it. If he asks you to code, you can code it, not a big deal. If you know the answer, you can code it. And what about design patterns? I haven't seen an interview where they focus much on design patterns, although you can of course tell it in the last that why you made a certain choice. In this example, I don't see a particular issue. I mean, there's no design pattern as such, but all you can do is you can follow, like you can say along the lines that I am declaring this class because I want it to I'm declaring the board class because I want it to just focus on the board. So it's a single responsibility thing where you're just altering the grid in this class and no other class. Things like that, right? Cool.